Well, you got climate control system. They're always changing. You know, they commonly use 3 to 5 pounds of refrigerant back in the day. Some of y'all might even have worked on some earlier that we had to put like 3 or 4 pounds of refrigerant in. You remember? It was something we did the other day that we had to put a lot of refrigerant. I can't remember what it was. It was one of the big SUVs. It was an older one. But the present day capacity is down to a point where a lot of them just hold 1 pound. It's like 1 pound, 1 1/4. Michael's car, 1.3 is all it needed to take when we were doing that the other day. Now you saw this little thing right here. This is the evaporator. You got little squirrel cage blowers on there, expansion valve, and it doesn't really, accurately represent what it looks like, but you see that. And then right here, your compressor. Which line is this? Anybody remember the name of that line? That's the discharge line, right? And this line right here is going to be going, because this one's got an expansion valve without a dryer on the liquid line. Now this is a big line coming from the firewall. It's cold all the way to the compressor. And so you got basically, you got to remember what's in here now. And here you've got low pressure liquid evaporating, changing into gas. Right here you've got low pressure gas coming to this compressor. Then the compressor squeezes it down into high pressure gas. And as it goes through here, it condenses and turns back into a liquid. And then it goes through the dryer and it goes back through the expansion valve, which is kind of like your little orifice. And that basically pinches that off and lets it spray out, and here's a low pressure liquid and starts all over again. Just remember that, it's really important. Now the R1234 systems are a little bit different. What they're trying to do on a lot of these now, and on some of your R744, whatever that is, the CO2 systems, a lot of times what they'll do is they'll take this heat exchanger right here and they'll basically have coolant, sort of like antifreeze, going inside the car that's cold because of the evaporator. Excuse me, that's inside the car there. And you might notice you basically, all your refrigerant stays under the hood, but you have cool liquid going inside the car. And it's got an additional heat exchanger up there on it. And that's got that, it's a sort of a different system. Did anybody know anything about R1234? The orange bottle with the red, the white bottle with the orange handle on it. You've seen it at the parts store, haven't you? What does it cost? 10 pounds of it costs $800, right? Did you know that? Yeah. All right. Here's your compressors. You got a swash plate compressor. Basically, as this one here spinning, you have a little compressor clutch here. It clicks in, and this pulley is spinning this on a bearing. And then as this hub pulls in, it's basically going to start spinning that swash plate, and that drives those pistons back and forth. I got some compressors kind of taken apart over on that. This right here is a variable displacement compressor that there's got a little piston in here that can change the angle of that swash plate. But typically this one here shows it's got a clutch, but most of these don't even have a clutch in them. They basically are just spinning all the time. And if it decides it wants to actually activate the compressor, it changes the angle of that swash plate. And the more it changes the angle of it, the more compressor you get. You got it? You understand that? All right. Then your scroll top compressor is the one that we just changed. Were you here on that deal, or did you miss that? Oh, you missed out on the second part of that job, did you? Because you were changing that compressor. That was a scroll top compressor that you just changed out. The one that you changed out on the Actuator, I believe. So anyway, this is various different things here. All right, you can see how when the shaft spins, the pistons move in a linear fashion. And this is a little video that I put together here, if I can get that to play. Might not be able to get it to play.
Something wrong.
I should have went ahead and had it done, but anyway, I'm basically showing you how I'm using that drill to do that. I wonder why that won't play. It should. Never mind, it's not a big deal. We can move on. Now, the variable displacement compressor got an internal piston and solenoid to change the angle of the swash plate on the fly. That's a little closer look at it, instead of disengaging and re-engaging the clutch. Even though they did a cutaway of this one showing a clutch, you can see that copper there. And if there's any of these that's got a clutch, I'm not familiar with it. There may be. And this right here was it. This right here was at the Ranshoe booth. Ranshoe makes AC compressor parts and all that kind of stuff. Everything's, they got everything's in pink. They got all this pink stuff and all that. These right here, in my experience, these scroll top compressors, they fail more than the other guys. I know that's Ford Fusion out here, not Ford Fusion, it's Ford 500 that Ms. Gooseby used to drive. We had to put an AC compressor on that one. It was a scroll top. And now these right here, it's not as, they don't tend to use quite as much power to do their compressing. In other words, they don't pull as much of a load, but they got to have good seals on the end of the scrolls and all that, and basically on the inside, you know, around that. Cabin air filters have been growing more common since about 1995 when they appeared on the Ford Contour. They can change airflow while you're clogged. It's really important when you're doing a full kind of service on a vehicle to make sure that you check and see if it has a cabin air filter. Like if you're doing on my Explorer, you wouldn't see a cabin air filter on my Explorer because they ain't got one. But at vans, a lot of them have got cabin air filters on them. And if somebody's coming in there saying, I'm hearing the blower, but I'm not getting good air, see what I'm saying? Go start looking for your cabin air filter. Somebody in here, may not be, maybe somebody's not here, pulled a cabin air filter out the other day. It was loaded with stuff. And it's always a good idea to change that. On some of those Nissans, they basically have, it's kind of strange because it's right up against the firewall where you got to pull that, I think it's a Nissan. Anyway, you got to, it's got a little old bitty place for the cabin air filter to come out of. It's as big as that, but it's when you grab a hold of it, it accordions together and pops out, and it's like twice as big as the hole you got to stick it through. And but now some of the parts store, they'll actually give you two filters where you can stick one in it.
Has two filters. You have to like line them up together.
Yeah, put them in there like that. On some of the GM vans and stuff, you open a glove box in there and they're behind that. And a lot of them are like, it's got to find out where it's at. They're not usually all that hard to change. Now, airflow control, you know, some of the Lexuses have horseradish in their cabin air filters to kill bacteria and stuff. Pretty cool. And some of them have infrared, you know, ultraviolet light. All vehicles today have electronic air doors, just about every one of them, with a small electric motor and plastic gears. They fail all the time. Whenever you'll hear it going pop, 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 pop. You heard that popping in the dash? You ever heard that? Pop, 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 pop. All right. Sometimes the feedback potentiometer of the control head can determine where the doors are, where they're even working. Now, if you change something like that, like on a Chevy pickup truck, like mid-2000s or something, if you change one of those actuators, make sure you follow the instructions. It's not plug and play. You got to follow the instructions and let the thing find out where both ends of the thing are. Now on your Fords and stuff, and even on some of the Impalas and all, you can just put it on there and it's okay. But some of the Chevy pickups, like if you put a control head on there, you're supposed to switch it on, not touch anything for a solid minute while it finds everything. And that kind of stuff is pretty amazing. You know, you can buy at the parts store the control heads that are aftermarket rebuilt ones. You know, so they're pretty common. You're going to be dealing with that kind of thing. Now this right here, you got your defrost door. This is basically like doors in that dash. This is some of the more aggravating stuff that you have to deal with when you come to the doors in the dash. That means you got to pull the dash out. You got to pull this whole assembly off of the dash. You got to tear it down and put them plastic doors in there. It's a little bit aggravating. Heater core, a lot of times you got to pull it off that. There's your blend door right there. When you're turning that knob that goes blue and red, you know what I'm talking about? The blue and red knob is going to be the one that decides how much warm air you're going to run through there. But every bit of the air that's coming in is going to come through the evaporator first, because dehumidifying the air is always a good thing. All right, so the S-Class Mercedes has 10 AC servo control motors. This is the ones that it has right here. And so it's just a mass of them right here. And they're basically, a lot of these German cars have got smart actuators and stuff, and they'll be on a big network. And the network will actually be going from both ways, so if one side of it fails, it can still talk the other way. It's a peculiar kind of thing. Mercedes S-Class uses stepper motors. Now each motor's got a power feed and several separate grounds, and a stepper motor pulses ground inputs across the rotate the motor core the same way GM and Craftsman other air controls work. Basically it does this with and it turns a little thing, it's got a screw and it can run it out and back in. And it can stop it anywhere it wants to, which is pretty cool. And there's your little digital thing and all that. The actuator motors in Mercedes air conditioner housing are identical design, but the task and the assignment of the flap takes place during the wire harness coupling. Once you got all of the wire harness connectors look just exactly the same going into these, but some of them have got jumpers in different places. And so when you jumper it, that little smart box, the ones that are jumpered is the ones that tells you, what that motor is supposed to be doing. On a Volkswagen, they got the same control head that fits a lot of different cars, but when you put the control head in the car, you need to go in there with your factory scan tool or whatever and say, this is what I'm going to be using this control head for. It's a Vanagon, or it's this, or it's that kind of vehicle. So it knows what to do with all of the doors and how much what it's got to handle and all that. And a lot of these vehicles now have got humidity sensors and this kind of thing. Well, a number of the expensive no-frill vehicles have got electronic blend door actuators for a long time, longer than that. The little Ranger out here, it's got an electronic blend door actuator. Why would they put an electronic blend door actuator in there instead of using something that's vacuum? See, this is an old blend door actuator off of an older vehicle, and it's a vacuum operated thing. And it's got 2 different vacuum ports in it. So it could kind of stop in a couple of different places instead of just going all the way this way and all the way that way. If you got an electronic blend door actuator, it can actually stop that blend door anywhere your knob stops. Gives a little bit of warm air, a lot of warm air, a little more warm air, all your cold air. You know what I'm saying? If you want to dial your temperature into a certain temperature, you know, these vacuum operated ones back in the day, they weren't that great about that. Furthermore, it defaults to defrost whenever you got vacuum operated ones and you lose your vacuum, defaults to defrost for safety. Got it? Okay, so almost as many different types of door actuators and systems there are vehicles. I mean, they're just all kind of, you can find these things all over the place. And you will have to replace some of these sooner or later. Some of them are fairly easy to replace. Some of them you got to pull part of the dash out and put them in there. All right, some of them are plug and play, some have to be learned. On the GM procedure, you put the ignition switch off, disconnect the scan tool, install the module. That's your HVAC module being your actual control pin. Connect all previously disconnected components, start it up, wait 40 seconds for the HVAC module to self-calibrate, verify that there's no diagnostic trouble codes. Like I say, it's going to drive all of the flaps back and forth and make sure it knows where the stops are. You know, in your power windows, have you ever seen these automatic cut power windows? What if you put your hand in there? What happens then?
Switch.
Huh?
Switch.
It stops and goes back down. Just like a garage door. Well, think about this. You got some little kid that sticks his head out there and stands on the button. You think they're going to let it cut his head off? No. They're going to go. I mean, if it gets a little bit of resistance, you can put your hand in there. All that Sonata we got, you can put it in there and it'll stop and go right back down. You know, because if it's blocked, you know, it just knows that. And they asked to know how many commutator pulses on that motor, you see. And all that. All right, on GM systems, the potentiometer is either driven by or integral to the output shaft. Signal varies between 0 to 5 volts to provide position. There's your potentiometer. It's integral to the output controller, and that one's driven by the output. See, they look slightly different, but they're pretty much doing the same job. Now this is kind of what they look like right here. I mean, as far as looking at the schematic of everything. There's your HVAC control module. You got a junction block. That's basically a place that all the wires go through. And then you got these little pins right here. And I'm going to show you how these pins are laid out and how you drive it back and forth if you want to test one. There's your air temperature door actuated right and left. All right. Now, all of them are pretty much the same way. See, there's a little potentiometer right here. This is a motor. You got some logic in there, a little circuit board and all that. And so the computer knows what to do there. Now, this is a really real close-up of that little pinout right here. That pin 8 is not used. All right, you got a 5-volt reference signal. You got a 0 to 5 volt position signal. This tells the HVAC module where it is, and the low reference is the ground. And then you got a control signal, 0, 2.5, or 5 volts, and then you got 12 volts for ignition voltage that gives the motor the power to operate. If you remove the right instrument panel trim end cover and access the right side instrument panel junction block, you can diagnose the actuator from the right-hand junction block on the CNK trucks and up to a certain year. All right. Here's your right instrument panel fuse block, and this is how it's laid out when you look at it in the shop manual. And see that this looks kind of complicated, but it's really cool whenever you get to where you understand what you're doing in there. All right, there's your fuse block. This is telling you what these pins do. Really important to know that. There's the other one. It's showing you what the pin's doing on that one. All right, so there's your actuator circuit pinouts on all that. Air inlet, right temp, left temp, mode, tells you what color the wire is, which cavity it is, circuit number, what color, you know, everything. Gives you everything you need to know. And your right-hand instrument panel fuse block connector. If you can find that, and you've got a good clear head on your shoulders, you can make this happen. If you take a 3-amp fused jumper wire and you go from here to here, for example, this drives the motor counterclockwise. See how useful that is? Like if you're trying to troubleshoot it, and you can actually get in there with your meter and look at that voltage change as that motor drives. See what I mean? All right, this drives the actuator counterclockwise, and this is basically what you're doing. You're taking your control signal and you're putting it to your, this is actually your control signal. If you ground that, it goes one way, and if you put 5 volts to it, it goes the other way. That's pretty simple, isn't it? See there? Not that much to it, really. Pretty neat. But you have to have a sort of a carnal understanding of how all this stuff works. And anybody that thinks they're going to go in there and wing it without being able to look at this, you're just not going to be able to do that. Now you can monitor the door position at pins 9 and 7. Go low reference to that one, and you can watch that reading change on the meter. We've actually done that in some exercises out here. The monitor position while you're driving the motor counterclockwise with a fuse jumper. And then monitor it while driving it clockwise with a fuse jumper. Just like that. See what we're doing here? Everybody get that. Up there behind you on that, you're going to find some actuators up there somewhere that are laid out like this. You know what actuators look like. Little plastic door actuators. The girl that works at the parts house. Yeah. Yeah, they're up there. All right. Look at that one. And that one. See, look at the pin. Look where the wires plug into it. You see them? Look where the wires plug
Back
in.
in my day, we don't need heater AC. You just roll down the window, there's your AC. Roll it back up, you get it.
You can look at where the wires plug in. That's what we're talking about right here. You can see how they got that. You see how that pin 8's not used, and you got 5, 6, 7, 9, and 10. And there's where they are. Monitor and control signal while changing door position with the controller or scan tool. If you just want to look at your door position by back probing the connectors where they plug into that thing when you're using your meter, you can tell your scan tool to go back. You can turn the knobs on the dash. I want it to go to defrost, I want it to go to floor, I want it to come out the register, I want it to go warm, I want it to go cold, whichever thing you're monitoring. And you can check the status of the circuits at the fuse block. Like you go to the fuse block and then you go here, you can basically see if any of these are shorted to ground. See, I'm going to go ground here. I want to see if any one of those, that one ought to be grounded, but these other ones shouldn't be, if they're pinched or something. You see what I'm saying? You got to know what kind of system you got. Right? Now to be able to familiarize yourself, where do you find that information? For what kind of system you got? Oh, you got a totally unfamiliar car. And somebody comes in here and say, hey, my air conditioner blows cold, but it's always blowing out on the floor, or it's always blowing out here. Okay, let's say that, let's say what happens here. Let's say that you say, I'm always blowing hot air. And so when you open the hood, you hear the compressor kick on when you turn on the air, and you feel the suction line, and it's cold. And it's cold all the way to the compressor. Everything, the pressures even look good on your gauges and all. Now what do? It's blowing hot air, but the AC system is working just fine. What's that likely to be? The blend door. All right, so how are you going to determine what you need to do? Is the blend door itself stuck because some kid threw a pencil on the dash and it went down the defrost and fouled it? That happens. Or a cigarette lighter will fall down in there sometime, you know what I'm saying? Okay, so you basically got to say, I'm going to take the blend door actuator and I'm going to see, can it move the door? If it can't move the door, I'm going to pull it off. Or if it's going to pop, 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 you obviously know you got busted gears in it, right? I'm going to pull the thing off of there and I'm going to grab that door and I'm going to see if I can turn it freely with my hand. And see if it changes the cold or not. Now, you got two water, coolant hoses going into the heater core, right? Right? Two of them, right? Yeah. You don't have three, do you? Yeah. Unless it's a screwball Jaguar heater core, and then you may have three. Okay, so, huh?
I got 4 on mine.
Oh, please, you're making it up as you go. All right, so what we got here, we got two heaters. We got a big one, and we got a small one. Which one's which? I need to know which one's the inlet, which one's the outlet.
The big one is the inlet, I do believe, and the outlet is small.
Really?
I might put my heater core backwards in.
That's backwards. You put it in backwards. All right, let me ask you this. You got your water pump. Whenever the thermostat's closed, the water is pumping. The water goes straight to the heater core, doesn't it? Mm-hmm. When the thermostat's closed, it goes straight to the heater core. And that water pump is not a positive displacement pump, but it puts up some pressure and it moves some juice. What if you pinch the one that's coming out of the heater core back to the engine? What's subject to happen
Putting a load on.
Maybe you busted the heater core. And it wasn't busted before you did that. You gotta make sure you know which way that stuff's flowing. But what you could do, if you pinch the one going into the heater core, and you can stop that coolant from going to the heater core, and it starts to get cool, you know it's a heater related problem, wind or whatever. Of course, a lot of these vehicles now you can push it, if you look it up, description and operation is what I was trying to lead you to a while ago. Description and operation, or if you pull up several codes, if it's got electronic temperature control of any kind, a lot of these vehicles that are, you know, it's a little bit different if you've got these, you know, big screen in the middle of the dash, so be careful with that. But, you know, the ones that's got just little green numbers, like these control heads, like that one right there. See that control head right there? Up, 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 that one. That control head. That control head right there. No, that one. Right by your hand. Left, 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 other left. There you go. Right there. Grab that one. Now see on that one right there, that's a control head. That's an AC control head that we swapped out. And you can actually, there's a certain pattern you're going to find where you push the off and auto or whatever. I mean, you got to kind of look it up. I don't ever have it memorized because we work on so many different kind of cars. But when you push it off, it'll actually go sweep those controllers, I mean those actuators, and tell you if it's got a code. See what I mean? And it'll tell you the code right there. Pretty cool because you don't even have to have scan tools to do it. All right, know how to read a wiring schematic. Know whether a scan tool will be needed. If you can do it that way, you probably won't need a scan tool. Some of them won't even talk to the scan tool. Some of the actuators are difficult to access. And know whether or not the actuator or control head must be reset. Sometimes just reset them, you know. Then you can unplug them, plug them back in. Know the mode door directs the air output. Mode door decides whether it goes up, out, or down. Got it? Blend door controls the air temperature. The max recirc door determines the air input source. Okay? And make sure you're working on the right actuator. Don't try to wing it. Read before you wrench.
I bet.
Are you a wing it kind of a person?
Well, I don't know.
You pretty much boast all your wrench, twist, and laugh in a winger.
Hey.
You know. And it helps when y'all look that thing up in the manual out there while you're going, saw how that motor mount was supposed to work in it. If you're just looking at it trying to figure out, I mean, you know, I like to go look it up first.
See, when I get home, I'll have internet, so.
Are you guys ready for a pop test? Now tomorrow, you know what we're gonna do tomorrow? We're gonna dig into some engine stuff. I got a PPT up here on engine stuff, and I'm gonna hit you guys with a test. After we get through, you better be paying attention. And if I decide to hit you with a pop test on this, you know, that'll be okay too, won't it?
Nope.
Pop tests are good, they're our friend. You know? Yeah, don't you love a pop test? Yeah. What about you? You like pop tests? You know?
I like
Did you get hit with those in high
I
school?
don't like pop tests.
You did?
Yeah, because everybody won't shut up.
Did you pass it? She gets a pat on the back. Michael is getting his work, and he's knocking along through that rear end thing. But she did that differential jump, did a pretty good job of it. You know, put all them tools together so you can measure it and all that stuff. Everybody in here has got to do that. She's the first one that did it. He's number 2. The rest of y'all are going to be following him behind him. But y'all are going to get that transmission in, and that car will be driving out here this afternoon, right?
Yep.
All right. That's what I like to hear. All right.
You need some coolant and some